Hi and welcome to this presentation of the Support and Hanger tool, part of MagiCAD for REVİT release 2016.4. This presentation is made for program internal training and education or any MagiCAD partner, however not for end users. The Support and Hanger is a tool for configuration and creation of suspension system for ducts, pipes and cable tray containments. It is for contractors and designers who do coordinated design, detailed design or design build. With the Support and Hanger tool they can easily create and configure suspension components and install it to a pipe, duct or cable tray. After the hangers and supports are installed into the installation model, the MEP model, together with architecture or structural model, clash detection and space allocation can be made to discover interference problem and coordination related space needs. With the Support and Hanger tool, the user can configure and optimize each individual support and hanger depending on the exact conditions for the individual suspension. Based on the configured solution made in the BIM environment, it will be possible to do cost estimations for support and hanger and cost saving by eliminating problems already in the model and not on site. In fact, by using MagiCAD Support and Hanger, it will be possible to shorten down the whole project delivery time by using a BIM-related workflow also for Support and Hanger objects. The target with the Support and Hanger tool is to have an extensive product library consisting of both manufacturer-specific databases but also of generic parts that are assembled into Support and Hanger objects. By having this opportunity, it supports both the possibility to buy ready-made Support and Hanger products from manufacturers or making themselves on the construction site. One of the key benefits is that the Support and Hanger parametrically calculates the needed measurements depending on the selected type and on the objects to be mounted. Another one is that if anything changes, the Support and Hanger automatically recalculates all the parameters for the Support and Hanger. And of course it's possible to also get configurable bill of material report from all Support and Hanger objects. For Support and Hanger manufacturer, this is a new opportunity to display their products for contractors and let designers use them already in the modeling phase. By doing that, they increase their chance of being selected as the chosen provider of the suspension system. A complete specification of all needed materials and quality can be possible to generate from a project. A specification that can be used for production of the Support and Hanger. The database is made by using the QModel builder and all files can be exported as RFRs or DXF files. Further on from the manufacturer, the sub-part specification of the Support and Hanger will be stored into a content database with all the information about sub-part types like product codes, material, nuts, bolts, etc. This practically means that bill of material reports can be configured to fit each manufacturer's specific product series. One of the main features of the Support and Hanger tool is that it can be both for generic and manufacturer-specific content as stated earlier. When the user selects an MEP object, the tool automatically looks for an appropriate host to attach to, like a wall, beam, slab, or similar. All this through a linked model. Then it automatically adjusts all the parameters to fit in between all the parameters to fit in between and around the segments and the host. If the duct, pipe or cable tray is changed in size, the Support and Hanger is automatically resized. If something needs to be changed on the supporting hanger, the user can easily by themselves parametrically edit the values according to the needs. If some of the host objects like the wall, beams, slabs or columns are changed or moved, the supporting hanger objects will automatically calculate and adjust to the new conditions. All standard supporting hanger types are pre-configured and the user just select which one to use. Multi-layer or multi-column hangers can be configured as well as multi-hosted supporting hanger types. A real powerful tool is the integrated hanger type. With that function, a user can attach one hanger type to another existing hanger and use that one as a host or part host for the complete assembly. The reporting tool is another powerful feature for the supporting hanger tool. The report can be configured and customized differently depending on the needs of the support of the report. Multiple tabs can also be stored. Multiple report types can also be stored. And of course, the report can also be exported to Excel. To keep the performance as good as possible in a project with maybe thousands of hangers, the detail level of each hanger has been kept to a minimum. But there's also a feature in the software to export the supporting hanger in high detail mode for the manufacturer specific supporting hanger types. So if there's a need to support the high detail model, that is also a possibility that exists. This was the PowerPoint presentation of this supporting hanger tool, and now I'm going to move into REVIT and we're going to have a look how this looks like in real. When MagiCAD for REVIT 2016.4 is installed into REVIT, you will find the common tab, ventilation, piping and electrical tab, but also the new MagiCAD supporting hanger tab. The first button on that ribbon is to install supporting hanger. This is basically the only button the user needs to know from scratch. Click on the button, select the duct, pipe or cable tray that you would like to install the supporting hanger on. Click then the finish button. The install supporting hanger dialog appears. If we look at the filter condition, you can see that there's a possibility to select whether to have a generic selection or a manufacturer specific selection. If the manufacturer selection is selected, the databases appear on the left side. But let's start with generic ones. Since I selected this install supporting hanger first configuration button, it recognizes the ducts and the allocation in the building and figure out automatically what possible types can be used for this specific hanger. So in the middle here we can see a number of proposals that are suitable for this specific conditions. We can also see that there's something called vertical rod, horizontal beam and layer count. Those three are filters. In this case it's filtering for vertical rods that has the shape or pattern of a rod, like O rod, O pattern. You can also filter for L or H. So if I, for example, take H beam and we look at the proposal here, we will see that in that case I have an H pattern for the beams. If I will switch to filter L, I will find the configuration that has L-shaped steel form. The same filtering of the steel shape or steel pattern can be done for the horizontal beams, whether I want H, EL, L or I beams or similar. Or I can basically use all to have all possible combination for this hanger type. The user then scrolls down until they find a suitable hanger type, or use any filter if they are sure that they want to have this broad hanger type, and then select this generic one pipe hanger suspender. If you look to the middle of this dialog, you can see the geometry. First comes the position. This is distance from this duct that is now 13,650 millimeter long, and the position where I clicked is 5,100 millimeter from the starting point. And then there's a possibility to select this axis where it should be negative or positive. There are also some possibilities to select and change pump parameter depending on the hanger type. And as you can see, you can switch within 3D, where you can zoom and rotate and check as normal with the Q modes. You also have the parameter names possible to display, and we can also switch to the 2D presentation of this component. If I'd like to have another or different length of this rod, I can change that directly to 500 or 600, and it will update them. Actually, in this case, push the duct system duct lower if it's possible. You can also see that there's a suspender part here that is now pre-selected since I used this before, but if I click on that row and I use those three buttons up here, I can open up a steel table list. This is the steel table GB from China market, but when this release is out, it also will be European norm steel tables, and basically select the steel type that the user would like to use for this specific rod. On this tab we have the base point, and here we have the available hosts, and in this case we have the slab or non-defined. So it means that this auto hosting is now made so that when I selected the duct, it looked around its location in the model and figure out that there's a slab on top of me, so let's attach to the slab. When I'm satisfied with my selection, I simply click OK, and my hanger type is then placed in the position where that I picked. If you use the 3D section box, we can look and see on this generic type that we just created very simply by just clicking on the duct, and it finds the location, calculates the size of the ring and the length of the rod depending on the duct size and placement in the model. That was the install support and hanger button, but there's also a possibility to go directly to any one of those filters for a specific hanger type. We can use the single rod hanger that filter out hanger types that only have are built up with single rods. We have the single layer hanger, multi-layer hanger, multi-column hanger, hangers that are for support on walls, hangers that are support for vertical ducts or pipes, multi-hosted hanger that attach are supported both in the slab or column and the walls. We have hanger types that are hosted or attached to the wall or slabs, standing, multi-layer version, and then we have the integrated version. So if we look at the single rod and we click on a same duct with clicked on before, then we can see that all those filters are now preset. So it's vertical rods, no horizontal beam, and layer count is 1. If you look at this section, we can see how this is made. I have here 3 ducts on top of each other. And if I would like to create a supporting hanger, here I can use, in this case, I will use the multi-layer hanger. So by clicking on any of those ducts, they will be taken into account when the supporting hanger object is calculated. So I select the first duct and I select the second duct, and I can also select the third duct if I would like that to be calculated. But in this case I'm satisfied by selecting 2 ducts, so then I click the finish button. To install supporting hanger, dialog appears again, and I can now make the settings for this specific type. As you can see, it's calculated a multi-layer type and the measurement for hanging those 2 rectangular ducts. We have positions with distance, and we also have some parameters. If we, for example, would like to change this parameter from 100 to 50, which is LT or RT, which is then those parameters, that is distance before from the horizontal beams to the duct, we can change it to 50, and then we can change the other one to 50 also, and then it's automatically calculated. We can select different type of cross arms or suspenders by clicking on the button and selecting a different steel type. I click OK and I install the supporting hanger. We'll also repeat this single rod installation and place this one in a similar location. We can now see that I have installed my supporting hanger for single rod and my multi-layer version, multi-layer type. And we're going to have a look at hosting, or actually we have seen the hosting, but now what happens if we start changing something with the hosting and duct sizes and duct pipes. If I now change this duct size here, I select the duct, and maybe I'm doing this by running MagiCAD sizing functionality for the ventilation module, or in this case I will simply change it to size 200 or to 250, and you can see how it's changed. And then after a couple of seconds the supporting hanger tool recalculates the ring length and adjusts the rod length automatically to the new conditions. If I decide here to move this floor, this is now not a linked model, but even if it was a linked model, it would work also. But let's say that this slab now will be moved to 3600. It moves up or down, and after a couple of seconds the supporting hanger is recalculated to the new situation. If I change the size of this rectangular duct, maybe I need it to be 600. After a couple of seconds, supporter hanger is recalculated. Maybe I like to move or need to move something, so I move this duct. After a couple of seconds, the whole new situation is recalculated and the supporting hanger updates. So this is what I meant during the presentation when we have this numbering auto size, duct is changed, hanger type is recalculated. Auto follow, if something moves, the hanger type adapts to the auto follow. If the host is changed or moved, or there's another host appearing, well, then there are special functions to be used. Like in this case, for example, update supporting hanger. Update supporting hanger is a similar function that is done automatically, but if the linked model has update or there's a new host, maybe the hanger was attached to a slab, but now after some update from the structural engineer, the beam has appeared, then you can update and it will rehost to the beam instead of the slab, or something else has been changed. The auto following or auto size or auto hosting is done immediately while you're working with the model. But maybe if you update the link with the model, update the linked model or similar, then the update supporting hanger can update to the new conditions, so you don't have to do it manually. There is of course a possibility to array. If I would like to array, I can set the space between the hanger types at the number, and then I basically select the hanger type I would like to array, and then it copies the amount of hanger types that I wrote in this dialog. One of the powerful functions in the supporting hanger tool is the integrated supporting hanger, and in this case I'm going to make a coordinated hanger type. So I'm going to combine hanging this new duct with an existing hanger type. So I'm going to go to the integrated hanger, supporting hanger type, select the specific hanger, and then the duct I would like to hang, and then click finish. Then I can select among the specific type that is now modeled in the Simfix database, and then depending on the situation I pick one type that is suitable for this occasion. But it doesn't matter, I take something else to show the functionality. And now we can see how this new hanger then attached to the existing hanger as an assembly type. If we do the same and we look at this generic one, we can of course use the integrated hanger also here. This one should be attached to that one, or vice versa. And maybe in this case I will use some of those clamps to hang with another hanger. I could also do so in this case, but maybe I didn't want that hanger type for the circular duct there, so I will do the same and I will coordinate those hangers. So I will use the integrated functionality, that hanger for that duct, and click the finish button. And then I might use one of those horizontal beams attached between the wall and the hanger. Let's do that. So, integrated hanger type is a possibility to combine existing hangers or integrate hangers with hangers to create specific assemblies. There's a possibility to use modify supporting hangers. So if you have an existing hanger that you would like to modify, click the modify and then pick it up and change the parameters, change the steel type or any other detail in this for this specific hanger. It's possible to copy a hanger, and we can have a look at that one. You might think, why use copy a hanger if you have REVİT copy? You can also use REVİT copy, but with a supporting hanger copy you can actually add a new duct to the type that you select if the situation is a little bit different. In this case I created that hanger type over here, and by using now copy this one I can tell that I want to use this type and combine that with that duct and circular duct, and then click finish, and then it copies the first type. You can see that it has now created use the same type but change the combination to support the rectangular duct and the circular duct, and it has not added this top rectangular duct because I didn't select that one. So there's a slight difference between copy with REVİT copy and copy with supporting hanger. You can also copy with REVİT copy, and it also has some smart functionality so it adapts to the situation. But with the REVİT copy you cannot add additional objects as I did in the previous case. If we look at some types here, or actually I can show you that I created some types here for, in this case there were some guilty hanger types that has been made, and you can also see that they have quite high detail here in the Q models. But if we look at them with the 3D section box, you can see that they are simplified. You have the steel pattern or shape, but there's no nuts or bolts, or very simplified model. But if we would like to have this as a high detail model, we could use the detailed support and hanger. This is basically a save as function, so if the user would like to create a high definition of some specific support and hanger type, that is possible then to do with this detail. In this case I'm taking detailed support and hanger. I select the hanger types that I would like to export, click the finish button. It calculates. It will take about 1 minute and 20 seconds, so I give an estimation how long it will take, and I just name this 1, 2, 3, and then it will create or actually do a save as, and then replace those selected hanger types with a less detailed model, to a high detailed model, as you will see after about 1 minute and 20 seconds. But I will cut the video and come back with the ready-made result, so you can spend 1 minute here waiting for this. So, conversion is completed. A little bit more than 1 minute and 20 seconds, maybe 1.5 to 2 minutes. 2 successful, 0 fail, 0 skipped. So we close that one and we look at one of the model. You already here see now that it's more detailed. If you look at the 3D section box. We can see now that there's more detail here. Now we can see that we have nuts, bolts, plates added to the model. We look at the upper type here. We can see plates, lengths that goes into the slab, rod lengths, etc., etc. Full detail model with all the details needed for manufacturing and configuration for manufacturing. So that leads us to the bill of material report. We can run the bill of material. There's like 3 standard report templates. General report is basically said support type and amount of support types. We have the summary report that gives you the support types and the total amount of steels and material summary, or you can go for the detailed report. You go for the current view, select all, click OK. The bill of material report is summarized. This one according to the generic one, the support made from Simfix and also from this Hilti database. If you look at the generic one, well, then we can also see the lengths, we can see the figure, we can see ID, part name, specifications from the generic system. If we will go into this Hilti part and we look at the one we just run in ID2 mode, you can see the different typicals, and here we can also see that we have a lot of detailed information: channel, flash anchor, pipe ring, saddle, threaded rods, nuts, part specification, mount, number of, and all the detailed information that is needed for the quantity takeoff for those hanger types. And of course it can be exported to Excel, export, and the export is reported and it's then separated in 3 material lists. So that ends this presentation of the support and hanger tool. If you have questions, you're welcome to contact me or anyone else in the development team or sales team. Thank you for listening.